Let us understand what is projection formula, how do we derive it, and how can we prove an identity using this particular formula. Enjoy the journey. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. In this video, we are going to understand a very important formula which is known as the projection formula. Most of my students in North America really do not understand this formula, nor do they ever use it. Well, if I am wrong, you can write them as comments. But it is a very popular question seen in many competitive exams and even board test papers of Asian countries. So what we have here is a relation between the sides of the triangle and the cosines of angles. You know the sine law, which actually relates sides of the triangle with the sine of the angle. Now projection formula relates cosines with the sides. So that is what it is. We are going to solve two different questions based on this concept. Now here is an identity. C minus B cos A divided by B minus C cos A is actually ratio of or quotient of cos B over cos C. A, B, C are the angles and A, B, C lowercase are the corresponding sides of a triangle. Once we do this, then we'll take up another identity which will be a practice question for you. I'll also provide solution for that also. But now let's begin with the projection formula and understand what is projection formula and how it can be derived. In most of the books, the derivation is kind of difficult. It comes from sine law or from other known facts. But we are going to have a very simple approach mainly because this is not well understood in Canada and in US. So what I'm going to do here is to show you what it really means, right? And what are we going to prove? We are going to prove these things that the side A is C cos B plus B cos C, side B is A cos C plus C cos A, and side C is B cos A plus A cos B. Well, very similar looking, right? Yeah, it is of course very similar looking. So what we are going to do is we have taken a triangle here ABC and we'll work on the side C and try to see how we can write this as a projection, right? Projection, you understand. The point C is right across, correct? So if I want to project something, how will I do it? Well, think about something like a lamp here, right? You will see the shadow of this line AC and which will be right like this, correct? At right angles. So now let's call this point as D, right? Makes sense, correct? So as you can see, what is AD equal to? Well, let's look into the cosine of this angle. So you know cos A is basically equal to the adjacent side AD over the hypotenuse which is AC, right? So cos A is basically equal to AD over the side AC which is B, right? So let me rewrite this as AD over B. So that is the nomenclature. If the vertex is A, the side opposite will be lowercase a. If the vertex is B, side opposite will be lowercase b. And if the vertex is C, side opposite is lowercase c. Makes sense, right? Now from here, we can very easily relate cos A over these two sides, okay? So we can say what is AD? We can write down that AD is basically equal to side B into the angle cosine which is cos A, correct? Okay, great. Now let's look into the other side, which is what is this side equal to, right? Well, let's look into the angle B this time, and so we can rewrite this as cos B as equal to what? Well, adjacent side BD over the hypotenuse, which is A, right? Let's rewrite A. So A can be written as we'll write it later, but at present, what is BD? So we'll write BD as equal to A cos B. Makes sense, right? So we have two different parts of this segment AD and DB as sum of AB, right? So these are my two different equations. As you can see, what is AB equal to, right? AB is AD plus DB, correct? So the whole length AB, which is side opposite to the vertex C, is actually C in a triangle. And AD, we just figured out, is B cos A. And DB is A cos B, correct? So we get our relation or side with the cosines of the angles. You get this whole thing, right? So this is the part 3 of our 3 equations which have been shown. You can drop a perpendicular on the other sides and do the same thing to get the other 2 equations, right? As you do in cosine law proof, right? Perfect. So anyway, I think the concept is absolutely clear and the name associated is also clear, right? Projection of a point on the segment right across is sum of the cosines multiplied with the side, right? So C is B cos A and plus A cos B, right? Similarly, we could have done for the other. And if I write B is what? So A and C, right? So A cos C plus C cos A makes sense, right? And A will be what? B and C, right? So B cos C plus C cos B. And that is how you get all the 3 projection formulae. Is it difficult? I think it's simple as that, right? The only thing is we are not learning it, and that's the problem. So I'd like you to really watch this once again and understand how beautifully you can also relate sides of a triangle with cosines of angles, right? Till now you have been only using sine law, relating these sides with sines of the angle. Why not with cosines? That's the whole question, right? Okay, great. Now, in test, we do have questions related to this. Now, we have this. Prove the identity C minus B cos A over B minus C cos A is equal to cos B over cos C. How are you going to prove it? Well, if you do not know the projection formula, and this is where we're talking about a triangle ABC, right? So I didn't mention it here, it should be mentioned in the question. So in a triangle ABC we're talking about, where A, B, C are the vertices and lowercase a, b, c are the sides of this triangle. So very clearly, we know what is C, right? So let's start with the right hand side. Right hand side for us is C minus B cos A divided by B minus C cos A. Okay, C is related with the cosines and the product over the two sides. So A and B, right? So A cos B plus B cos A, correct? That is what C is. So I wrote C using this projection formula, right, given there, which we just proved, right? Now the other thing is, we'll just rewrite the other thing, which is minus B cos A over the denominator B can be related with cosines of A and C, right? So, okay, A cos C plus C cos A. Makes sense, right? And here minus C cos A. Great. So, if you see this, minus B cos A and B cos A will cancel out, right? And in the denominator, C cos A and C cos A will cancel out. So, what are you left with? Well, we are left with A cos B over A cos C, correct? A and A will cancel out. So you get cos B over cos C. So in three lines, we actually get the solution, provided we understand what is projection formula and how it can be applied. Is that clear to you? Well, with that, now here is your practice test question. Simple as that, right? So this time we have C minus A cos B over B minus A cos C equals to sine B over sine C, right? So I'd like you to now apply the projection formula and prove this particular identity. I'm going to take the solution in the next video. So watch the playlist for learning how do we apply the projection formula effectively. Perfect. So with that, we'll end the video, right? And then take up the same question in the next video. Perfect. In case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Also, feel free to support your own channel in which we actually share with you quality videos which are being watched worldwide in more than 80 countries. Your contributions matters. Every dollar you contribute matters. Thanks for your time and contributions. Thank you and have a great day.